Namaskar. Welcome in online learning process. I am Mrs. Rekha Sagar from Bitco Junior College, Nasik Road. Today we will start 8th topic from physics, that is electrostatics. In this video we will discuss about introductory part. First see this video completely till up to the end. Then once again come to the starting. Look at these animated images one by one. These images will help you for more understanding of some basic concepts.
Here we will discuss about charge, electric field, electric force, electric lines of force, electric flux, and analogy between gravitational field and electric field.
Now see this example. You might have noticed that these light pieces of paper are attracting toward this ball pen, which is of plastic. Why does this happen? On rubbing it with hair, it becomes charged. Same thing will happen when plastic comb is rubbed with hair. Yes or no? Now I will explain this using one more example. If you will consider this balloon and when it is rubbed with this wool, what will happen? Both will get charged. On balloon, negative charge is there, while on wool, positive charge is there. And when these charges are produced, you can say this is nothing but one example of charging by friction. Now, what are these charges? Or simple way, what is this charge? This charge is nothing but physical property of matter that causes it to experience a force when this is kept in electromagnetic field. Means this charge is nothing but having certain property. When this charge is kept in electromagnetic field, then it experiences the force. This is how we can define this charge. Now generally these charges are of two types, positive charges and negative charges, and we know when unlike charges are there or opposite charges are there, they are attracting. When same charges, positive positive or negative negative or like charges, they will get repelled. Unlike charges are attracting, like charges are repelling. This attraction or repulsion, it depends on this Coulomb's force. So what is this Coulomb's force? I will explain this. Now see, these two are the charges Q1 and Q2, which are like charges. So there is force of repulsion. In second case, this Q1 or Q2, these are unlike charges. So there is force of attraction. This force of attraction or repulsion is given by this mathematical form. This F is Coulomb's force of attraction or repulsion, which is directly proportional to product of magnitude of these charges and inversely proportional to square of distance between them, where this r is distance between these two charges. Got it? So once you will remember this in mathematical form, you can write down statement. Further, we have to replace this uh, proportionality sign. So we have to introduce one proportionality constant, and this proportionality constant is 1 upon 4 pi epsilon. QQ upon R square is as it is. Now this is the complete formula for Coulomb's force of attraction or repulsion. Now in this formula, if you will see here, epsilon factor is present. What this epsilon is? काय बरं हा epsilon? This epsilon is nothing but permittivity of that particular medium. Now we must know what is this permittivity. To allow, to permit, or we can say that it is the ability of that particular substance to store electrical energy in the electric field. Means this F is depending upon these two charges, no doubt. It also depends on distance between these two. And one more point, it depends on this epsilon also. Means up to what extent the force is. Who will decide this? No doubt. Capital Q, small q or r. And in addition to this epsilon. लक्षात आलं? मग आता epsilonची concept. This epsilon is nothing but, once again read it, ability of the substance to store electrical energy, that is indirectly, up to what extent the force is there, up to what extent the intensity is there. Like this, the permittivity of the medium is deciding. Now further, this epsilon is called as permittivity of the material, or this epsilon 0 is called as permittivity of the free space or air or vacuum. What is difference between these two, epsilon and epsilon 0? Just I told here. Now there is relation between this epsilon and epsilon 0, and this relation is given by the factor dielectric constant, or it is also called as relative permittivity. So what is this dielectric constant or relative permittivity? It is denoted by K or epsilon r. This r suffix indicates relative. So relative permittivity or dielectric constant is ratio of epsilon and epsilon 0, or even you can write down this relation. Epsilon is K times epsilon 0. Remember these formulas. Electric field. See, what is this electric field? It is some region around a given charge in which unit positive charge is kept. Then it experiences the force of attraction or force of repulsion. कुठल्याही चार्जच्या भोवती जो रिजन असतो त्या रिजनमध्ये जर आपण एखादा युनिट पॉझिटिव्ह टेस्ट चार्ज ठेवला तर तो फोर्स experience करील. I will explain this using this diagram. See, this is minus q charge, and in its surrounding region there is electric field. If we will keep this positive unit test charge at this particular position, then it will experience the attractive force in this direction. Or second case, this is positive q charge. In its surrounding region there is electric field, and if we will keep this positive test unit charge at this particular position, then it will experience the repulsive force in this direction. Got it? Now next point, that is electric lines of force. Just I told you, this unit positive test charge is either moving towards or it goes away from that charge. So this electric lines of force, this is nothing but it gives the idea, that is the path along which the test charge is moving. Okay, I will explain this using this example. Imagine this is plus q charge. In its surrounding region there is electric field. If test charge is here, it will move in this direction. If test charge is here, it will move in this direction. If test charge is here, it will move in this direction. Means these are the paths, either this one or this one or this one, along which this test charge is moving. This path is nothing but electric lines of force. Now here, when charge is positive, then from positive charge, electric lines of force are always away in all directions, like this, here or here or here. This is a three-dimensional. We have to draw it in two-dimensional. This is positive charge, and electric lines of force are like this, or here or here or here, like this. These are the electric lines of force of this positive charge, always outward. If negative charge, then always towards. This is or this one or this one. Electric lines of force are here. And if dipole is there, this is supposed to be our first charge, this is second charge, then this is nothing but direction along which the test charge is moving. Means it starts from positive and end towards negative, means this is again electric lines of force, either this one or this one or this one. Once again see, this electric lines of force is nothing but path along which unit positive test charge moves in the field. Electric flux. See, what is this electric flux? This is nothing but total number of electric lines of force per unit area through the given area. How many electric lines of force are passing? This is given by this electric flux. How to find out this electric flux? There must be some formula. Now let us discuss about this. For this purpose, consider this is one body, shape and size is as shown. In this, at this particular position, O plus Q charge is kept. Now since charge is positive, electric intensity or force is in this direction, away from the charge. Now out of this body, we will consider the small area element ds, and through this small area element, how many electric lines of force are passing, or what is this electric flux? We have to find out this. For this purpose, same area element ds is considered here. This area element I have drawn here. Clear? So this is the direction of electric intensity. Now what about this E cos theta? What this E cos theta indicates? This E cos theta is the component of E along this normal, where this normal is perpendicular drawn to this area, and theta is angle between this E and this normal. Then to find out electric flux through the given area, which formula we used in 11th standard? We already discussed about this. Yes, tell me. See, this is that formula. This is the electric flux which is given by E ds cos theta. Remember this formula. Now see some particular cases. If same area element ds is held here in such a way that normal to this area and direction of E both are same or parallel to one another, then what about this d phi? What is electric flux, or how many electric lines of force are passing through this area? Tell me. See, this is that value. D phi is simply E into ds, because theta is 0 and we know cos 0 is 1. That's why this E into ds, this is the electric flux through this area. Means when area is held in such a way that normal to this area is along E, the electric flux is maximum. Second case, when same area but it is held in such a way that normal to this area is perpendicular to E, then what about electric flux? सांगा किती येईल? This electric flux will be 0. Why? Because theta is 90 in this case, and we know this cos 90 is 0. That's why this d phi is 0 when area is held in such a way that normal to the area perpendicular to E. Means in this case there are no any electric lines of force passing through the given area. Got it? Now see, in these three cases, d phi is nothing but the electric flux through this much small area. If we have to find out total flux through this entire surface, what we have to do? सांगा काय करावं लागेल? Yes, by integration we can find out total flux. So this phi is the total flux through this entire surface. Is simply integration of d phi. Replace this d phi, so E cos theta ds or E ds cos theta, and integration of this will give this total flux. Now remember always this formula, flux is integral E ds cos theta. Gravitational field. In previous standard, we discussed about this field, too many formulas in this field, definitions are also. If you will remember these formulas in gravitational field by analogy, you can write down formulas in electric field and finally even in magnetic field also. See for this, now this gravitational field is caused by masses. What about electric field? Tell me. This electric field is caused by charges, yes or no? Next, in gravitational field, the force is there and that force is attractive force. While in electric field, the force is attractive or repulsive. Next to this, in gravitational field, it obeys inverse square law. While in electric field also, it obeys inverse square law. Now in gravitational field, the force of attraction is given by this mathematical form, or this is mathematical form of Newton's law of gravitation. What is this Newton's law of gravitation? The gravitational force of attraction is directly proportional to product of the masses and inversely proportional to square of the distance between them. Similarly, we can write down electric force, that is called as Coulomb's force. What is this electric force or Coulomb's force? This is the F, which is directly proportional to, instead of these masses, what we have to substitute? These two charges Q. Means this electric force or Coulomb's force is directly proportional to product of these two charges and inversely proportional to square of the distance between them. लक्षात आलं? क्लिअर झालं? Now next to this, we have to remove this proportionality sign. So we have to introduce one proportionality constant. So G is proportionality constant in gravitational field. While in electric field, this proportionality constant is nothing replaced by 1 upon 4 pi epsilon Q upon R square is as it is. क्लिअर झालं का बघा? मीन्स इन ग्रॅव्हिटेशनल फील्ड proportionality constant is G. In electric field, proportionality constant is 1 upon 4 pi epsilon. In gravitational field, two masses are considered. In electric field, two charges are considered. No doubt, R is the distance between two masses or two charges. It is same. In gravitational field, the gravitational intensity is given by force per unit mass. That's why we wrote this formula. While in electric field also, the electric intensity is force per unit, tell me, force per unit charge. So again, this G you have to replace by 1 upon 4 pi epsilon. Capital M you have to replace by capital Q and R square is as it is. Means again by analogy you can write down this formula. Further, gravitational potential, work done per unit mass. What will be in electric field? Electric potential, work done per unit charge. And again you can write down formula very similar to the previous one. Similarly, gravitational potential energy is work done, which is minus gmm upon r or minus mgh. Electric potential energy, which is again work done. Again, G you have to replace by 1 upon 4 pi epsilon 0 and mm you have to replace by this QQ. Clear? So by analogy also you can remember these formulas, you can write down formulas, you can write down definitions. So in this way you can, by comparison or by analogy, you can write down formulas in electric field or in gravitational field or even further in magnetic field. Now while remembering formulas, in this sequence only you will remember force, intensity, potential and potential energy. In all these four cases 1 upon 4 pi epsilon is common. So in force QQ upon R square. In intensity Q upon R square, means in this case only 1 Q. In electric potential, Q upon R, means instead of R square only R. In potential energy, QQ upon R, means in which formula two Q's are there, or single Q is there, or R square is there, or R is there. In this sequential manner you can remember.
Thanks for watching. Enough for this lecture. But before going to say bye, read these some lines and see what these lines are indicating. Once again, thanks for the watching.